All right, guys. So in section 10.2, we used factoring to help us solve quadratic equations. However, not every equation is going to be factorable. And so we're going to need some other methods to help us solve. And the first one that we're going to look at is what's called solving by square roots. And this is kind of a special type of solving. It only works if the quadratic equation is of the form ax squared plus c is equal to 0. In other words, there is no middle term. There is no bx term. And when that's the case, we can use solving by square roots. So in order to do that, here's your step-by-step. So step 1 is you're going to isolate x squared. In other words, get x squared by itself. For example, if you had x squared minus 49 equals 0, then add 49 to both sides, and that will give you x squared is equal to 49. So then step 2, we're going to take the square root of both sides of the equation. So that would be the square root of x squared is equal to the square root of 49. And on the left side, your square root and exponent of 2 are going to cancel. That's just going to give you x. The square root of 49 is 7, but we need to make sure and write that it could be positive or negative 7. And the reason for that is, if you think about it, 7 squared is 49, but also negative 7 squared, which would be negative 7 multiplied by negative 7, is also 49. In other words, you always need to put a positive or negative sign in front of the variable. The other way you could list your answer would be to list them both separately and say that x equals 7 and that x equals negative 7. So that would be the other way that would work. So notice that there are two solutions. You can either write those using plus and minus, or you can list them out separately. Now, the other thing to mention is that you cannot have a negative underneath the square root sign. If the number inside the square root sign is negative, then what we're going to say is that there is no solution. So if you ever end up with a negative under the radical, that's going to be no solution. And then just remember, a positive number always has two square roots. That's what we talked about with that plus and minus. Okay, so let's get into some examples. So on this first example, we've got x squared minus 16 is equal to 0. So just like we did on the previous part, we're going to get x squared by itself. So add 16 to both sides. So x squared is equal to 16. Then go ahead and take the square root of both sides. That way square root and your exponent of 2 will cancel. That'll just be x on the left side. The square root of 16 is positive 4. But remember that both positive and negative 4 are your answers. And then don't forget that you can also list those separately and say x equals 4 and x equals negative 4. Okay. For the next example, we've got x squared plus 1 equals negative 9. So again, let's get x squared by itself. So let's subtract 1 from both sides. That'll give us x squared is equal to negative 10. And then we'll go ahead and take square root of both sides of our equation. That way square root and exponent of 2 on the left side will cancel. But on the right side, square root of negative 10, you can't take the square root of negative numbers. It doesn't work. And so this is going to be a time where we'll just say that there is no solution. All right. On the next example, we've got 3x squared is equal to 108. So let's start by getting x squared by itself. So we're going to actually start this time by dividing by 3 on both sides. That way we can say that x squared is equal to 36. Next, we'll go ahead and take square root of both sides of our equation. That'll leave us with x on the left side, and the square root of 36 is 6. And then don't forget to say that both positive and negative 6 would work. And then if you want to list those separately and say x equals 6 and x equals negative 6, that would work too. Okay. So in the next example, we've got negative 2x squared is equal to negative 98. So kind of like what we did before, we're going to go ahead and divide by the number in front of x squared. So divide by negative 2. That way on the left side you have x squared, and the right side you have positive 49. Now that x squared is by itself, we'll go ahead and take square root of both sides. So now on the left side you just have x by itself. Square root of 49 is 7. Make one of them positive and one of them negative. So then x would equal positive 7, or x would equal negative 7. Okay. Now let's get into where there might be a couple of steps to go before you would be able to take your square root. So in this next example, we've got 3x squared plus 7 is equal to 199. So step number 1, let's go ahead and subtract 7 from both sides. That's going to leave us with 3x squared on the left side is equal to 192 on the right side. Now we'll go ahead and divide both sides by 3. So that'll leave us with x squared on the left side is equal to 64 on the right side. Now that x squared is by itself, we'll go ahead and take the square root of both sides. So that'll leave us with x on the left side is equal to, square root of 64 is 8, so make that plus and minus 8, and then you can write those separately and say x equals 8 or x equals negative 8. All right, next example is going to be very similar. Let's go ahead and solve for x squared first. So we'll go ahead and subtract 66 from both sides. So that'll leave us with 7x squared on the left is equal to negative 63 on the right. Next, we'll go ahead and divide by the number in front of x squared. So divide both sides by 7. That'll leave you with x squared being equal to negative 9. And now that x squared is by itself, we'll go ahead and take the square root of both sides. So on the left side, square root and exponent of 2 will cancel. That leaves you with just x. On the right side, even though the square root of 9 is 3, we cannot do anything with the square root of negative 9 because it's a negative number underneath the radical. So again, this is going to be a time where we will write no solution. So again, anytime that number underneath is negative, no solution is going to be what you'll put for your final answer. Okay, let's look at a few more examples. I think we've got 4 more to look at, and then we will be done. So in the next example, we've got x squared plus 36 is equal to 10x. So let's do this. We can do it really a couple different ways, but the easiest way is actually going to be to subtract x squared from both sides. Since all of your numbers are on the left side, that'll leave you 36 by itself. And that gets you all the variables on the right side. 10 minus 1 is 9x squared. And so really we're just working this problem kind of backwards. We've got the variable on the right side, but we're going to do all the same steps. And if it kind of bothers you, just switch the two sides of your equation. Write it as 9x squared equals 36, and that would work too. But I'll go ahead and leave it like this. There's nothing wrong with it. Let's go ahead and get x squared by itself. So let's divide by the number in front. Divide by 9. So now we've got x squared is equal to 4. And now we're ready to take square root of both sides of our equation. So on the right side, we're left with just x. And on the left side, the square root of 4 is 2. And just make sure to put plus and minus. So your two options this time are that x equals 2 and also that x equals negative 2. All right, on this next problem, we're going to have to move actually a couple things now. So we need to get variables to one side and then numbers to the other. So let's go ahead and do this to start. Let's just go ahead and move all of our variables to the left side, since that's where we would probably be more comfortable with them anyways. So let's start by just subtracting 2x squared from both sides of our equation. So on the left side, 27 minus 2 is 25x squared. Still have a plus 5 is equal to, on the right side of our equation now, is just 30. So now that we've done that, let's go ahead and get all of our numbers to the right side of the equation. So let's go ahead and subtract 5 from both sides. So that'll give us now on the left side 25x squared is equal to 25. So now we need to get x squared by itself, so let's divide both sides by 25. So that will leave us with x squared by itself on the left side is equal to 25 divided by 25 is 1. Now that x squared is by itself, we're ready to take square root of both sides. So on the left side, that leaves us with just x. And on the right side, the square root of 1 is just 1. But don't forget to include that plus and minus sign. So then if you wanted to write them out separately, you would just say x equals 1 and x equals negative 1. All right, 2 more equations to look at, and then that should be good for today. So in this next equation, we've got x squared plus 2 is equal to 46. So first thing we need to do is get x squared by itself. Let's go ahead and subtract 2 from both sides of our equation. So that will leave us with x squared is equal to 44. So now let's go ahead and take square root of both sides of our equation. On the left side, that will give us the just x by itself. But on the right side, we've got a little bit of work to do. Before we simplify, let's make sure we include our plus and minus. And now for the square root of 44, which I'm just going to copy down, we need to find a perfect square that we can divide by. And the reason for that is obviously 44 itself is not a perfect square. But the perfect square we can divide it by is that 44 is divisible by 4. In fact, you could rewrite 44 as 4 times 11. So let's go ahead and do that. Everything else is going to stay the same. So it's still x plus and minus square root of 4 and the square root of 11. Now keep in mind, square root of 4 is going to simplify. Square root of 4 is just 2. And again, just copy down everything else, so everything around it stays the same. And at this point, square root of 11 cannot simplify, so we have found our final answer. Now, just like we have on the previous problems, if you wanted to write these as 2 separate solutions, one of them would be a positive 2 multiplied by the square root of 11. The other would be a negative 2 multiplied by the square root of 11. So you can still break it apart, even if the number is not a whole number. All right, one last example. Let's take a look at it now. So we've got negative 5x squared plus 130 is equal to 10. So first thing is we need to solve for x squared. So let's start by subtracting 130 from both sides of our equation. So on the left side, we now have negative 5x squared. And on the right side, we have negative 120. So now let's go ahead and divide by that number in front of x squared. So divide by negative 5. So that's going to give you x squared on the left is equal to a positive 24 on the right. So at this point, we have x squared by itself. That's when we're going to go ahead and take square root of both sides. So that'll leave us x on the left is equal to both positive and negative, so plus and minus. And for right now, let's just write it as the square root of 24. Now again, square root of 24 will not simplify by itself, so let's go ahead and break it down into a perfect square that it is divisible by. Once again, 24 would be divisible by 4. We could rewrite 24 as the square root of 4 times the square root of 6. Everything else, again, will stay the same. And then just like the previous problem, that square root of 4 is going to simplify to just be a 2. And then just copy down everything else that was around it. So it looks like x is going to be equal to both positive and negative 2 multiplied by the square root of 6. And then finally, if you want to write those answers separately, then one would be positive 2 squared is 6, and the other would be negative 2 squared is 6. All right, so guys, that is it for solving by square roots. Really pretty straightforward. It's kind of just like solving a linear equation, just with that extra step of taking a square root. In the next section, we're going to look at what's called the quadratic formula. And while it is a fairly big formula and can be hard to remember, the nice part is that you can use it to solve any quadratic equation that you ever come across. Until then, have a good rest of your day.